Hi guys, in today's video we're going to look at how to select the formulae we use, skeletal formulae, unsaturated hydrocarbons, cyclic hydrocarbons, aromatic hydrocarbons, alcohols and carboxylic acids, and finally we'll look at an exam style question.
How we select the type of formula that we use. Well, we've talked about displayed formula in our previous video, and we talked about how it is used to show all the atoms and bonds within a molecule. Now that can be particularly useful when we're considering the shape and size, because we are drawing out all the bonds involved. But it can also be particularly time consuming, as we have to draw out all these atoms and bonds, which in a large molecule may be particularly difficult. So we use another type of formulae. That's called our skeletal formulae, which can be much easier. So let's have a look at the skeletal formulae. Well, it's actually quite brief, and this little zigzag here is actually a type of skeletal formulae. The corners and the ends of our lines, such as here and here, represent where a carbon is located, and the lines indicate alkyl chains, and we really fill in the gaps with our hydrogens. So this squiggle is actually the skeletal formulae of this compound, CH3, CH2, CH2, CH3, which we know to be butane. So if we look, we have a CH3 group here because we have a carbon on the end of an alkyl chain. It's bonded to 3 hydrogens. That's bonded to a CH2 group because it's also got another bond coming off it here. We have another CH2 group and finally a CH3 group. Again, this is our butane molecule. So now let's have a look at how skeletal formulae can be used to represent unsaturated hydrocarbons. Well, unsaturated hydrocarbons are organic. They contain only hydrogen and carbon, and they contain at least one carbon-to-carbon double bond. They are part of the alkene family. So as you can see, we again have a skeletal formula here. Now let's see how many carbons we would have here. We'd have 1 there, 2, 3, 4. So again, you can see the stem of this is going to be bute. Now we have a double bond, and the double bond is actually represented just as you would normally. It's represented by 2 lines.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.
So our question is asking us to translate the skeletal formula into display formula and then name the compound. So I'm going to start by quickly noting down what we've got in this formula. Then we'll translate that into proper display formula. So we have 1, 2, 3, 4 carbons in our longest chain. So I'm going to draw out a chain of 4 carbons. Then we know on the end of one of our carbons we've got an OH group. We also know that on our first carbon we have 3 H's. On our second carbon we have a CH3 group over here. On our third carbon we also have a CH3 group. So we can fill in what we haven't got here to see that this would have 2 H's like this. So what we have is we have CH3 bonded to a CH with a CH3 group coming off, another CH with a CH3 coming off, CH2, and finally an OH group. So now let's draw our displayed formula, remembering to show all the bonds. So we have 1, 2, 3, 4, OH. Here we have 1, 2, 3 hydrogens. We have 1 hydrogen here. We have another carbon here, bonded itself to 3 hydrogens. Another hydrogen here, carbon bonded to 3 hydrogens, just try and fit it all in, and 2 hydrogens. There we go. So now we've got to name our molecule. So our longest chain is 1, 2, 3, 4 carbons. So we know that we're going to have a stem that is bute. Now, have we got any groups on here? Well, yes, on our second and third carbon we have methyl groups. So that would be 2, 3 dimethyl. And do we have any functional groups? Well, actually we do. We have an OH, so it's going to be an alcohol. So the molecule is 2, 3 dimethyl, di meaning 2, 2, 3 indicating there's 1 CH3 group or 1 methyl group on our second carbon and 1 on our third carbon, and then we have butanol. Excellent, so now let's summarise what we've learned today. Skeletal formula is the briefest way of representing organic molecules. Unsaturated hydrocarbons are organic compounds with at least one double carbon bond, which is C+C. Cyclic compounds have a circular shape. Aromatic hydrocarbons are very stable 6 carbon structures with a formula of C6H6. They include at least one benzene ring. Alcohols are represented by an OH functional group, and carboxylic acids have a COOH functional group.